Welcome back, Algebra 1. So we're still working on the same packet, Unit 1, Packet 1, interpreting and evaluating algebraic expressions. So we've gone through a lot. I want you to get to this last page here. Simplifying algebraic expressions. All right. Definitions. So you've heard me use these terms before. Now we're going to actually define them and give examples. Okay, so a variable is an unknown quantity or an unknown number represented by a letter. All right. Go ahead and put an example right here that we can reference. So our example is going to be 3x plus 2y minus 10. So I've got two variables in this example, right? My variable examples are x and y. We have two variables, x and y. They're unknown quantities represented by a number. Are they the same quantity, or could they be the same? No, they cannot, and that's because they're two different letters. If they were the same quantity, then they would both be the same letter. All right, next up, constant. A quantity that does not change. So I want you to think number by itself with no letter. Number by itself. All right, so our constant in this situation would be a negative 10. Now I know you're thinking, wait a minute, why is it not a positive 10? Remember, if there's a subtraction sign, it sticks into the number and stays with it. So the constant would be negative 10. All right, coefficient. You've heard me use this before as well. So it is a number used to multiply a variable. A number used to multiply a variable. So it's the number in front. Oh my gosh, I just spelled front. In front of a letter. A number in front of a letter. That's it. We know that operation is multiplication. So the coefficient of the x term is 3, and the coefficient of the y term is 2. I'm giving these examples right here. All right. Term. Expressions are made up of terms. So terms are a separate number or a variable separated by plus or minus signs. So looking up here, and I'm going to use this line right here for like terms. Looking up here, we've got three different terms. We have 3x, we have 2y, and we have negative 10. Remember, if it's a subtraction sign, it stays with that number that it's in front of. So in my example up here, we have three different terms. We have 3x, comma, 2y is our next term, comma, and negative 10 is our last term. So we have three terms. All right. Now, like terms are terms with the same variable and same exponent. So, for example, 2x squared and 5x squared. Do they have the same variable? Yes, x. Do they have the same exponent? Yes, squared. Now, 3x doesn't have an exponent. If there is no exponent, I want you to assume a number 1. So go ahead and tell me on the Edpuzzle free response, what would be a like term with 3x? What would have the same variable and same exponent as 3x? All right. So here's our example. Let's go ahead and identify each vocabulary term. So variables, let's go ahead and list them out. So variables are the letters. So looking at this, I only see two variables. I see an X and a Y. So I'm going to write 2 in the corner because there's two variables. All right, how many constants do you see? And what are they? All right, I see 2. They are -9 and +7. Remember that subtraction sign stays with the 9. So -9 and +7 because it's a plus sign in front of 7. All right, what about coefficients? Remember, to have a coefficient, you also have to have a variable, right? So it's the number in front of the variable. So let's see, I've got 1, 2, 3, and 4. Now looking at that last one, you say there is no number, right? But from here on out, if we have a letter by itself, that means I have one of those letters, right? I have one X. So there's an unseen 1 in front of that letter. So overall, I have 4 coefficients. The first one is +5. The second one is +13. The third one is -2. And the last one is 1. So the 5 is in front of the X, the 13 is in front of the X, the -2 is in front of the Y, and 1 is in front of that last X. All right, the number of terms that we see here, remember they're separated by plus or minus signs. So I've got 1, 2, 3, 4, 5, 6 total. And let's write them all out. We'll separate them by commas. So the first one is 5x. The second one is -9. Remember that subtraction sign stays with that number, so it becomes a -9. We've got 13x. We've got -2y. We have 7, and we have x. So that's 1, 2, 3, 4, 5, 6. All right, and what about our like terms? Remember, it's going to be same variable, same exponent. So do I have any like terms with 5x? Yes. 5x, 13x, and x are all like terms. Same variable, which is x, same exponent, which is 1. Remember, if I don't see a little number at the top, that means it's understood to be a 1. All right, do I have any other like terms? Let me see. I don't have anything else with a y in it, so I don't have any like terms for that. But what about the two numbers? Could they be considered like terms? Yes. So constants are always like terms. So if there's a number by itself and another number by itself, they are always like terms. So constants are always like terms. There's a weird star. Okay. So -9 and +7 are like terms as well. Okay. Our last step here, steps to simplify an algebraic expression. So to get it down to its simplest form, we've really got 2 steps. Number 1, use the distributive property. Remember, we went over that last class. Use the distributive property to get rid of any of the parentheses if there are any. We have to do that first because think about your order of operations, your PEMDAS. Step number 2, combine like terms. Remember, like terms are same variable, same exponent. Or if we've just got constants, those are like terms as well. All right, let's do it to it. Number 1, simplify each algebraic expression. All right, so we do have parentheses, so I do need to use distributive property. Now I'm going to distribute the 8 because it's on the outside. So once I do that, distribute means multiply, right? So distribute means multiply. All right, so 8 times 2x is going to give me 16x. 8 times 3 is going to give me 24. All right, so I expanded that out. So I've done this part. Now just add the rest of the expression, minus 9x. So you see how we distributed the 8, and then we just finished writing the expression. All right, so that was step 1. What about step 2? Combine like terms. Do you see any like terms that we can combine? What do you see? All right, I hope you said 16x and negative 9x. They are like terms because they are the same variable, same exponent. The variable is x, and the exponent is 1 because you don't see any number there. So I'm going to combine them, and when I say combine, we're talking about adding and subtracting. All right, sorry I wasted your time with that. All right, so we're just going to add and subtract. I hope you downloaded the app Desmos on your phone. You will definitely use it at some point. I'll go ahead and write it down. Desmos. It should be a free app like this. All right, so we're going to combine 16x and negative 9x. So all I'm going to do is 16 minus 9. Now I know what you're thinking, Miss Lucas, wait a minute, you said that was a negative 9. Okay, you're right. I can do that too. I can do 16 plus a negative 9. I get the same answer. 16 minus 9 is 7, and 16 plus a negative 9 is 7. So there's multiple ways to get at the right answer. Whatever makes more sense to you, use it. So 16 minus 9, or 16 plus a negative 9. You end up with 7. So 7x plus 24. I don't see any other constants, so this is the most simplified version. Now, could I put the 24 first and the 7x second? Well, that's a great question, Miss Lucas. No, you cannot. So, when we're ordering things in standard form, variables always come first. So we have the variables first and then the constants. All right, I want you to go ahead and try B on your own. So see if there's any parentheses that you need to clear with distributive property, and if not, then you can go ahead and combine like terms. So go ahead and do that one. Pause the video and then come back. All right, hope you paused the video. So step 1 was use distributive property to clear parentheses. I don't see any parentheses, so step 1 is good. Step 2, combine like terms. All right, so we need to see what like terms we have. Like terms are same variable, same exponent. So I see 2a, that's a b, so that won't work. And I see 7a. All right, I don't see any other b's, and I don't see any other constants. So the only thing that I need to combine is this right here. So 2 plus 7. 2 plus 7 gives me 9. So 9a. All right, now that I've combined those, just go ahead and add these next two terms next to it. So 9a minus 3b minus 9. That's as simple as I can get because I don't have any more like terms. There are no other a terms, there are no other b terms, and there are no other constants. So this is my final answer. All right, go ahead and try C. This will be the last one that we do on the Edpuzzle video, and we'll wrap up the rest of this packet in class. Pause the video and try C. Okay, so step number 1, use distributive property to clear parentheses. Okay, I have 2 sets of parentheses here, so I'll just have to do both of them one at a time. I'll start off going from left to right. So 6 is what I need to distribute. So I'm going to distribute 6, meaning multiply, right? So 6 times y is 6y, and 6 times negative 4 is a negative 24. All right, so I did that. Let's look over here. I hope you noticed the subtraction sign in front of the 3. Remember, it stays with that 3. So consider this a negative 3. Negative 3 times x is going to give me negative 3x. Negative 3 times 2 is going to give me a negative 6. All right, now that I distributed, let's go ahead and take a look and see if I have any like terms. Y and x are not like terms because they're not the same variable, but negative 24 and negative 6 are. All right, I combined them by doing negative 24 minus 6, or you could have also done negative 24 plus negative 6, as long as I've got both of my negative signs in there. You get the same answer either way, negative 30. So my final answer is going to be 6y minus 3x minus 30. And that is my most simplified version.